What is blockchain? In 5 minutes. The blockchain is based on a block, which is a batch of data linked in a chain. As we already know, Bitcoin's blockchain is something like an accounting register, or a ledger, containing the information about all the transactions made with Bitcoins. While blockchain is an accounting register, its blocks are the pages. All the financial transactions are recorded there, and they are linked between each other by the hashes. So a heading of each block contains the hash code of the previous one. This enormous registry leaves no chance to delete a page, block, or change its content, because this would influence the content of all the following blocks. Such spoofing attempt will be easily noticed by any member of the Bitcoin distributed network. This won't be hidden from the system itself, so all the efforts will be denied. Thus, all the blocks that were already written in the blockchain cannot be changed. In general, editing the information written in it is restricted. The only thing left is to record new blocks. This is a critical blockchain feature as of a distributed ledger of financial transactions. One cannot rip out the pages from a stamped ledger, and so it is about the blockchain. At the same time, blockchain is way more safe than a ledger or any bank register of operations, because its copies are stored on a lot of computers, servers, in a distributed peer-to-peer network. But let's get back to Bitcoin blockchain blocks. Not those blocks. Every block consists of a head that contains service information and payload, transaction record itself. Blocks and connections. The block's name contains the following information. 1. The block's version. 2. The date and time the block was created. 3. Hash code of the block's name. 4. Hash code of the previous block. 5. Hash code of all the transactions in the block. 6. Specific parameters, nonce and bit, recorded during the mining process. We need hash codes in the names for better understanding. The hash code of the title is a feature that links the previous block with the following one. It's recorded as a hash code of the previous block in the title of the subsequent one. The naming also contains hash codes of the current block. It's calculated using an algorithm known as Merkle tree or binary hash tree. So, let's see how it works. First, hashes of all the transactions in the block are calculated. Then, hashes of the sum of hashes of the transaction pairs. Then comes time to calculate hashes for the sum of the hashes pairs and so on, until there's just one hash code left. This code will be the transactions code of the block. As the tree is binary, every step should consist of an even number of elements. Therefore, if at any level the quantity of hashes is odd, the last one is duplicated merely to form a pair. It's titles that allow tracking the integrity of the block's content. So, let's move to the payload's content. As we already know, the transactions are recorded into the blockchain. The transaction itself looks like this. Send N bitcoins from address 1 to address 2. The transaction is more complicated because of Bitcoin protocol operated with such concepts as inputs, or in, and outputs, out. Inputs are transactions that fill up the Bitcoin address, and outputs are sums that are transferred to other Bitcoin addresses. That's why all the new transactions through the input, one or several, refers to the output, one or several, of the previous operations and forms outputs, one or several, to be used in the following transactions. New transaction C refers to two incoming transactions A and B. As a result of the transaction, we have 0.008 BTC, 0.005 plus 0.003, which is later divided into two outs. 0.003 BTC is sent to the first address, and 0.004 goes to the second one. The balance is 0.001 BTC, and it goes to the miner. The record's transaction consists of number of the inputs used, hash code and index of each input and service information, a number of the outputs used, sums of the outputs, and service information, a time code of the transaction. This structure looks complicated at first sight, and it shows how money is moved between Bitcoin addresses. It also allows counting a balance of any address based on its inputs and outputs. Note: in fact, the balance is determined by counting all the unspent outputs. so-called UTXO, unspent transaction output, of the address. Possibly to indicate more than one output in the transaction is an important feature, because the transaction's output can be used as an input only once and just as a whole. For example, if there's an incoming transaction input for 1 Bitcoin, BTC, and you need to transfer 0.8 BTC, a deal with 1 input and 2 outputs is created. A transfer itself in the amount of 0.8 BTC and a 0.2 return to the sender's Bitcoin address. Important notice, there's a transaction fee paid to miners. Miners are people who write down new transaction blocks into blockchain. The amount of outputs in this transaction is usually more massive than the number of inputs, and the distinction is sent to the miner's address. That's the miner's reward, besides the payment he gets for the creation of a new block and the mining itself. That's all. Now you know what blockchain is. Subscribe, put likes, etc. See you!